we're doing problem 48 on page 404. So we're going to start by writing the equation that they give us. So it's a reaction between potassium hydroxide and hydrobromic acid. So we just wrote that out. Next, we're going to look at the ionic equation. And notice that there's two spectators here. So we have Br minus and K plus. So these are just going to be, we're going to just eliminate these on both sides. So there we go. And then finally, we're going to end up with the reaction H plus OH minus yields H2O. And we know that since this makes sense because we have a strong acid and a strong base, so this is always going to be the net ionic equation. All right, so next is asking what species are present at the equivalence point. So we know that it's going to be K plus and Br minus because if you look at the ionic equation that we have here, we have K plus and Br minus. Those are spectators and they're in the product side. So at the equivalence point, when the reaction has completed, we're going to have H2O and the K plus and Br minus. So next we're looking at what volume of potassium hydroxide is required to reach the equivalence point. So given that we have the molarity and volume of the hydrobromic acid, we can solve for moles. So we're going to get 0.009 moles. And we know that at the equivalence point, moles of acid is going to be equal to moles of base. So we're going to rewrite this quickly. And they give us the molarity of the potassium hydroxide. So we can just solve for liters because we have the moles. So it's going to be 0.0654 liters. And yeah, okay. So then next we're going to find the pH of the solution before any KOH is added. So this is actually pretty simple because they give us this right here, the 0.257 molar hydrobromic acid. So all I have to do is take the negative log, and we're going to get 0.590. And then for part E, so you can, since it's at half equivalence, that's what we're looking for, we can use half the moles because we know that it's going to be 0.045 moles that have been converted to H2O, and then there's going to be 0.0045 moles of H plus that are left. So that's why we're using half of the moles. And then for the bottom here, this is the half of the total volume of potassium hydroxide needed, and this is just the other volume that they give us. So we just add those two, and then we're going to get that the molarity is 0.0664. And then if you take the negative log, we can get the pH equals 1.18. And finally for part F, since this equation, the net ionic equation is H plus H2O yields H plus OH minus yields H2O. We know that it's going to be a neutral solution and the pH is going to be 7. Thank you for watching. I hope you enjoyed that.